Hello everyone. In today's video, we will discuss how we can utilize the angle bisector theorem to derive some trigonometric identities. So let's get started. Let ABC be a right angled triangle, right angled at B, such that angle ACB is bisected by CD and the length of the hypotenuse of this triangle, that is AC, is 1 unit. Now if we use the definition of sine in the triangle ABC, this is what we get. AB, that is perpendicular, by AC, which is hypotenuse, is equal to sine of the argument, that is 2 theta. But because AC holds the value 1, it simply vanishes away and sine 2 theta unit is the value AB acquires. Similarly, if we use the definition of cos in the triangle, we infer that BC is equal to cos 2 theta. Notice that CD splits AB into two parts, AD and DB. For convenience, let me call the top P and the bottom will be named Q. CD not only splits AB into two parts, it also bisects angle AC, allowing us to use the angle bisector theorem to state that cos 2 theta by 1, which is cos 2 theta, is equal to Q upon P. If we multiply both the sides of this equation by P, we express Q in terms of P and theta. So P cos 2 theta is equal to Q. Clearly, if we combine P and Q, if we add them, we get AB, which is equal to sine 2 theta. That is how we get our second equation. If we substitute the value of Q from the first equation into the second, it changes to P times 1 plus cos 2 theta is equal to sine 2 theta. If we divide this by P sine 2 theta, this is how it looks. 1 plus cos 2 theta over sine 2 theta is equal to 1 over P. Using the first relation, if we just play around with it by rearranging the terms, you can deduce that 1 over P is cos 2 theta upon Q. Then 1 plus cos 2 theta by sin 2 theta is the same as cos 2 theta over Q. If you observe carefully, you will notice that in the right angle triangle DBC, Q with respect to theta is the perpendicular of the triangle and cos 2 theta with respect to theta is the base of that triangle. By definition of cot theta, base upon perpendicular is cot theta. That is, cos 2 theta upon Q is equal to cot theta. And this is exactly 1 plus cos 2 theta by sin 2 theta. I think you are getting the feeling of accomplishment. If we separately divide each of the terms present in the numerator by sin 2 theta, we change it to cosec 2 theta plus cot 2 theta, and that is how we derive the cot half angle formula using the angle bisector theorem. Not only that, if we flip this equation over, the LHS, thanks to the identity, changes to cosec 2 theta minus cot 2 theta. And what is cot theta's reciprocal? It is simply tan theta. So see, angle bisector theorem can help us derive the half angle formulas for cot theta and tan theta. Isn't that amazing? But you know what? We can even derive the double angle formulas for sin 2 theta and cos 2 theta. So let me know in the comment section if you figure out how these equations can assist us to derive sin 2 theta and cos 2 theta formulae. And that is it for today, guys. If you like this video, give me a thumbs up with any of your fingers. Share it with your friends, and the most important thing, subscribe to Math Thrill. Bye bye.